Hello everyone. Today we're gonna learn about greedy algorithm. This is a simple algorithm. It is too simple that it's not very useful most of the time, but we're still gonna learn it because it's very popular. A lot of people knows about it, and when we hear people discussing about it, we should know what it is and how it works. This tutorial is a part of the data structures and algorithm class. First, we're gonna have a look at a typical problem solved by greedy algorithm. The word greedy here makes it easy for us to remember this algorithm. That we're gonna make the greediest choice in current step and hope for the most optimal solution after all steps. So that's how greedy works. Making the greediest choice every time and hope for the most optimal solution after we finished. Let's have a look at this example here. We are given three types of coins. $5 coin, $2 coin, and $1 coin. We are also given a sum, in this case $21, and we are asked to pick up enough coins to make up the amount of sum here, 21, with one condition, which is we have to pick the minimum number of coins. If we present this problem in math, we call x the number of $5 coin, y the number of $2 coin, and z the number of $1 coin. Then we are asked to find x, y, z, where 5x plus 2y plus 1z equal to 21, and with a condition of x plus y plus z to minimum. That is our problem. Find the minimum number of coins to sum up to the amount of 21. Now let's think about brute force solution for this problem. We have one equation with three variables. So there's a lot of options for us to choose x, y, and z. For example, if we choose x is 1, y is 1, that makes up to 7, then our z gonna be 14. And one solution gonna be one $5 coin, one $2 coin, and 14 $1 coins. That is the total of 16 coins. And we intuitively know that it's not the optimal solution that we want, because we can choose more $5 coins. With problem like this, we can see that we have a lot of options. Too many options actually. And that is when for loop and nested for loop failed to provide a quick answer. And when brute force fails, here come greedy to see if we have a solution with a simple logic. And the logical greedy choice is we're gonna be really greedy. We're gonna get as much bigger coins as possible. And then if a solution is found, the total coin number must be minimal. So with that thought in mind, in step 1 we're gonna be greediest with $5 coin, the biggest value coin that we have currently. So with the sum of 21, we can have maximum 4 $5 coin. That's gonna add up to 20, and the remainder is 1. And with the remainder of 1, we're gonna make the greediest choice again. So in step 2, the biggest coin that we can have is $1 coin, and we're gonna have 1 of it. So one $1 coin gonna make it to 1, and our remain is 0. And in this case, by being greedy, we found a solution. Thus we're gonna have 4 $5 coins and one $1 coin to make up to the amount of 21, and the total coin that we have is 5, which is the most optimal. In this particular case, when we say that we are being greedy and always pick the bigger coins first, we actually have already considered all inputs. We have considered all the coin types, 5, 2, and 1. So we know that 5 at the first step is the biggest coin type. And with this joy of considering all inputs, if we found a solution, we can prove that the solution is the most optimal solution. So in this particular case, where we have coin types of 5, 2, and 1, and the sum is 21, being greedy gives us the valid, most optimal solution. But unfortunately, it doesn't work like that all the time. Let's say that we have another case. In this case, we have coin types of $5 and $2. There is no $1 coin. And if we apply the greedy choice every time, greedy is not gonna give us a solution. So for step 1, we have the greediest 4 $5 coin. That make up to 20, and we have the remainder of 1. And then we stuck there, because we don't have a $1 coin. So we cannot use any coin to make up to this remainder of 1. And then we don't have a solution. So thinking greedy in this case has failed. There are other algorithms, which is more complex but guarantee the most optimal solution. For example, dynamic programming. In this case of the sum of 21, it's gonna give us 3 $5 coins and 3 $2 coins to make up the amount of 21. and we're gonna learn about dynamic programming later. And today we just focus on simple greedy. Next, let's have a quick look at the implementation of our greedy algorithm. First, we need to sort the coin types, big to small. We can print them out. Then we can run a loop through all the coin types. Then we get the maximum number of bigger coin every time, and we save it to the result object. We also save the remain in the result object. If the remain is 0, we file a solution. Then we return the result object. And if we run our greedy algorithm with the coin type 1, 2, and $5, and the sum is 21, this is our result. We're gonna have 4 $5 coins, and we're gonna have a $1 coin. And this is a valid solution because we have no remain. But if we don't have the coin type of 1, and the sum is 21, greedy fails to provide a valid answer. So we're gonna have 4 $5 coins, and we still have a remain of 1. As you can see, being greedy at every step is a simple algorithm. And simple algorithm can only deal with simple problems. Like this one we have here. When we have $1 coin type, we are guaranteed to have a solution. Because $1 coin type can make up to any amount. But when problem gets more complicated, greedy has failed to provide a valid answer. Next, we're gonna generalize the characteristic of problems that can be solved by greedy. Because of the nature of the greedy choice, it's very suitable for maximization and minimization problem. The input characteristic is a wide range, which can be array, string, or graph. And when we see maximization or minimization with these kinds of inputs, we can think about greedy. But remember that greedy does not guarantee the most optimal solution. And the time complexity varies depending on how we implement the algorithm. And because of this uncertainty, we do not recommend to use greedy in coding interview. Because in coding interview, you are required to provide the most optimal solution. But you can actually use greedy in real-life application if there's no choice left. Because having a less optimal solution is still better than having no solution. Next, let's have a look at another problem. In this problem, we are given a binary tree, and we are asked to return a max sum path from root to leaf. And the way greedy solves this is, whenever we have to make a choice between two nodes, we're gonna choose the bigger node. For example, in this case, we start at root node 5, and then we have to choose between 2 or 3. And greedy make it simple for us. We only need to choose the bigger node. In this case, that's gonna be 3. Now, it's important to note here, when we make this decision of choosing either 2 or 3, we have not considered all inputs, which are all the nodes after 2 or 3. And because of this, even we find a solution, we cannot guarantee it's the max path because we never know what do we have on the other side. In this case, after choosing 3, we have 7. And 5 plus 3 plus 7 is gonna give us 15. It's a solution, and in this setting, it happens to be the most optimal solution. It's important to note that this is just a coincidence. If we have a look at another tree setting like this one, and this node here after 3 is 1, it's no longer 7, and the node after 2 is 8. If we keep being greedy by choosing the bigger node, we're gonna have 5, 3, and 1, which add up to 9. And this is not the max path. And the max path is actually 5 plus 2 plus 8, which is gonna give us 15. By this example, you can see, using symbol greedy, especially with a combination of not considering all inputs, will never guarantee the most optimal solution. If we happen to have the most optimal solution, that is because either the problem is too simple or we are too lucky. Next, we're gonna have a quick look at our greedy implementation. This is to construct our binary tree, and this is our greedy sum path algorithm. We're gonna use recursion. Here's our exit condition. If there's no node left, we're gonna return the sum. If there is a node, we're gonna add it up to the sum path. And then we're gonna choose to go either left or right with the bigger node. Then we return the sum. And if we run this for the first binary tree setup, we're gonna have our max at 15. And it's happened to be the correct answer. And with our second binary tree setup, if we run this, it's gonna give us 9, which is a wrong answer. Next, we're gonna summarize our greedy algorithm. So whenever we see a maximization or minimization problem, and the input is array, string, or graph, We can think about greedy algorithm as an option if there is no option left. And greedy does not guarantee the most optimal solution. And the time complexity of greedy varies depending on how we implement it. So again, max-min problem. Greedy is an option if there is no choice left, because it does not guarantee the most optimal solution. But if you have no choice left, having a less optimal solution is better than having no solution. That is all for today's tutorial. Thank you for watching, and I will see you in the next video.